Hi, greetings to Dr. Manos. My name is KYAI LUN. I'm from Department of Computer Science. Now I'm going to present about proposals about my presentations in Iipspw. So my project title will be the Malaysia's currencies recognizes mobile applications for visual impairments. Alright. So what is the current problems? People with visual impairments are having difficulty when they recognize objects through visions in daily life, and especially for the principal daily use objects such as banknotes. It's hard to let a visual impairments to recognize the banknotes. And so, the mobile applications nowadays was also not accessible by visual impairments, and this is because of most of the mobile applications are not really got the feedbacks of the visual for through the voice channels and the physical conductions, and then this leads them to out of touch to the environment changes. And then here is some related research about the existing applications to recognize the mobile application, the mobile applications for the classifier banknotes. And first of all, is a cash readers by Martins Dodera. And this is the only one able to recognize Malaysia banknotes in all of my research, and but it cannot identify both sides of the banknotes. It just can recognize for the front side of the Malaysia's banknotes, and then have in the navigation system, it's not very user friendly to visual impairments due to there's no voice feedback to tell the users where is the current situations on the applications. And then next will be the MCT's money readers by the MCT data. Now, these feedbacks in the applications, the feedback results are not deliverable to users, and most importantly, it cannot recognize Malaysia banknotes. And then the third one will be the ideas currencies identifiers by the idea group INCs. And in this their settings are not user friendly to ensure impairments, and it also cannot recognize Malaysia's banknotes. And the fourth one will be the cash recognitions by the Kishtis remote, and it cannot recognize Malaysia's banknotes at the moment, and as well as the previous applications. And then the last one that I reviews will be the Myanmar money readers by the Myanmar Assistive Technologies, and it's also had the same problem that it cannot recognize the Malaysia banknotes. And then one of the notifications of only alerts the users once when the no banknotes were detected. These kinds of serious problems that the mobile applications are not very accessible by the visual impairments. And then lastly, there are no feedbacks to user to inform the current status of the applications. So this is all the reviews for the existing mobile applications. And then in the next one, we will be talking about the machine learning techniques into the back research. So basically, more of them, the machine learning techniques will be on the feature extraction. First one, the feature extractions on classifications, the banknotes will be the first of all RGBs, extract the colors, and then shift extractions, extract the location point, and then surf extraction is the same things. And go to the classification models, we got KNN, the K nearest models, DTCs, decision tree classifiers, SVM, support vector machines, and abelian sense classifiers, and implements all this in these machine learning techniques. So how now I will be talk about the critical remarks on the previous works. So first of all, the applications such as not able to recognize both sides of the banknotes and no proper feedback to the users are most importantly, there is no recognition of the Malaysian banknotes for most of them. And then the performance is not stable due to the different design of banknotes. And from different countries, different machine learning techniques will be applying for them the banknotes itself. So it's very that the banknotes will be result on different machine learning techniques they're using. And most importantly, got one problems that they're using for the research to recognize the banknotes will be the RGB extractions. But in that one will be a serious problems when it got a very good accuracies on it to classify it, but when go to the real life, when you implement into mobile application and start to classifying, you use if the same colors regions will be detected as the banknote also. This is the weaknesses of more of the research in the previous. So The last, in order to have a better usage for the visual impairments, some improvement on visual impairments friendly need to integrate into the mobile applications. So move forward. And what is our aim and objective in these projects? So we're going to develop Malaysia's banknotes recognizes mobile applications, and then we're going to implement machine learning techniques to recognize the banknotes. We target to recognize a 1 ringgit, Malaysian ringgits, 1 ringgit, 5 ringgit, 10 ringgits, 20 ringgits, 50 ringgits, and 100 ringgit. And we're going to ensure the accuracy results and deliver the results in real times, and then ensure there is no problem that such as the previous works like is only using the RGB abstractions. So the second sub-objective will be develop the mobile applications that are accessible by the people who have difficulty on visual impairments. Because since our features to machine learning will be implemented inside the mobile applications, so the mobile applications will be designed to feedback through voice channels and physical conductions through vibration to let more accessible for the visual impairments. And then here is our contributions. We aim to help the visual impairments to recognize Malaysia banknotes in real life. So first of all will be the daily transactions that they're doing transactions, and then second count the banknotes, and then easier, and then to the last one will be recognize the Malaysia banknote, because currently will be receives some counterfeit or even not Malaysia banknotes, then they don't even know this is the Malaysia banknotes. So this will help them in their daily life to recognize the Malaysia banknotes. So how exactly we implemented behind of these all features? So we're going to trainings of machine learning models to classify Malaysia banknotes, which is a supervised machine learning model. And then here is a brief about the flow about the machine learning methods and techniques. So first of all will be the image acquisition, which is to collect the images into a database, and then we're going to image pre-processing, and then features extractions, and then next will be apply machine learning models to classify it, and then the last step will be evaluate the accuracies and then stabilize it. And then there will be more details about each steps. So the first step, the image acquisitions. The image will be collected by the phone cameras, which are Xiaomi's smartphones, and 100 images of each of the Malaysia's banknotes, just like shows in the pictures there, will be collected as our image data sets. So it will be front and backward types. All the images will be collected. And then the second steps will be image pre-processing. So since we take by the cameras, then we need to focusing on the part or the regions we desire to classify, so there is no noises behind. So we're using the extract the interest regions of the image by region segmentation. It's just so like the image there, it extract out the parts we're going to classify only. So third part will be feature extractions. So feature extraction is a very important steps for classifying, because all classifying the properties will depend on the features. So at now we're going to objective to classify the banknotes, right? So the banknotes, the main things of the banknote is image as input, and then the main features actually is the color of it inside, because the Malaysian banknotes are very in different colors. Like the 1 ringgit will be the blue colors, and then 5 ringgit will be green color, and then forward. So actually when the RGB abstractions come out, the channels will be got difference, and then the intensities level also will be different. So just like I counter the problem I just stated just now in the previous research. So for this features extraction, we're going to use C-surf techniques, which is the idea from combinations from the RGB abstractions and then the surf extraction techniques. So now I will going to brief about how it actually works for this C-surf techniques. So like just now said RGB abstractions, we're going to take from the input images with RGB abstractions extract to the red channels, green channels, and blue channels, and just like shown in the picture there. And then secondly, we're also using the surf extractions to increase the more features specifically to extract out to more easier on the classifications and more accuracies. So what is surf extractions? So surf algorithms is a novel scales, rotation invariance detectors, descriptors, and second order Gaussian derivative with a box filter, which can be calculated fast through the integral images. The localizations of the interest points is determined by the determination of Hessian matrix. Interest points are finally located in the scale space. The image space are using no maximum suspensions in their 3x3x3 neighborhoods. And in construction of the descriptors of an interest point, a circle regions will be around the detected the interest point is the first constructed. Surf is descriptors is constructed by extracting the square spot around a point of interest. So it's just like an image there. They extract the images in the interest of point and then have indicate all the vectors out. And then here is how the C-surf's extraction flow will be like. So first of all, the read of the banknotes images, and then second stage we'll be using the RGB extraction instead just now to form the image of red channels, green channels, and blue channels. And then we're going to use the surf dynamics which locate the corner points vectors of each of the red color, green color, and blue color channels. And then after we locate it, we extract out the features and then we combine the vector back together using and then extract features, and then the feature extractions completions with a vector like combined with the both we extract just now. So for the classification model, we're going to use the SVM, which on the previous episode we did really a very good and desires accuracies to these classifications of images. So SVM support the multi-classes classification through 1 versus 1, and then use a multi-class classification for banknotes. So after inside it will be classifications in the image like got labeling the class 1s with the vector features is the RM1, and then class 2 with their vector features in the for the RM5, and then so on. We'll be have 6 class in our studies in these projects. So how we average the results? It's very simple. We average on the purpose machine learning models using the cross validations with k-folds to measure the performance and classifiers, which means the accuracies will be count like the all number of the banknote samples and the number we correctly predicted using our machine learning techniques. So in the other hands, we're going to develop mobile applications. So how are we going to develop on it? Our aim is to build a mobile application to recognize Malaysia banknotes, and most importantly, it was user-friendly for visual impairments. So we're going to use Flutter, which is a quite new software SDKs for building Android and iOS mobile app SDK. So here will be the rough app designs prototypes. We're going to go through it, and then at first the cameras will be enabled applications, and then open the camera, the vibration mode will on and notifies the application is running, and then when start recognizing, the flashlight mode will on, and to get a better images to recognize it. So the mobile camera real-time will be real-time captures in just like in the images put into the like point to the RM1, and then it will detect it and will vibrate to the user, and then we will say that RM1 is detected by the voice channel. So here we ensure the accessibilities for vision impairments. We provide the voice channels feedback to the users and navigations. We notify user the application is running by and using the vibrations, the physical conductions, and then we using the live stream for image capture in real time. This is a very interesting and very accessible for the vision impairments, because they're just like using the phones and then just simply direct go to the images, and then we'll automatic real-time captions and give back to the users. And then here is our tools in use in these projects. So in hardware, we're going to use the laptop Asus ROG G531Gs, and then using a smartphone Xiaomi Pocophone F1s for our mobile application testings purpose. And then in software, we're going to use the Spider or Jupyter notebooks and OpenCV. These two are for mainly designed for the machine learning platforms to integrate code inside them and then test it out how it's the accuracies result. And then for the Android Studios and Flutter is the main purpose for developed user interface and the mobile applications overall there. So here is our project timeline, how we're going to develop and deliver the applications out. So first of all, in the first phase, we'll be going to have a project conception initiations. We establish the objective, we plan the review, we initiate it in January. For this, the start dates will be on the 1st January of the 18th in next year, 2021. So we will start of that, and then in the phase 2, we will be going to sprint cycles. The sprint cycles will be divided the backlog task, which is our objective we're going to implement inside it. We're going to take about 2.5 months to achieve our objective and then apply it out. And then the phase 3 we will be going to the project closures, which we will start the complete documentations, and then lastly will be project submissions, and at April of 9 we'll be doing final checkings and submissions. And then here is the project budget. So basically the budgets will be the electric bills, the internet plans, and the Azure cloud service. For the backend service we're going to use on the cloud there, so it can perform through internet when using the services we're using the machine learning, right? So the amount will be like 1,749 cents and 76 cents. Okay. So here is my conclusions. In this project, we aim to build a mobile application that will bring difference for the people who are suffers in vision impairments. We bring a Malaysia banknotes recognizes mobile applications to their daily life and help them to recognize banknotes in the easiest and accuracies, and also in such an interesting way for them. And then in the future plannings, we will consider to move on to add the Malaysia coins recognitions features to these mobile applications and make it offline capable. Due to this, more testings capable, we're going to use the HTTP calls will be in the cloud side. In the next step, in the future, that after we all compile it, we'll be we're going to make this offline capable to make it use without internet. So here is all about my projects to build a mobile application for visual impairments to recognize our Malaysia banknotes. So thank you. Okay.